I'll do this one by hand, not because it can't be done with Ansible, but because I think you need to learn to be comfortable with LXC commands, attaching to LXCs, and making changes directly. Also, upgrading iRedMail usually requires manual intervention, and it's not something you can automate easily. You'll need to edit postfix or dovecot configs, make some database schema edits, and so on. So doing it from the terminal by hand is probably the way to go. On the VPS, I'll first create a directory named LXC in root's home directory, where we'll keep all our Linux containers. Then I'll create a directory specific to iRedMail container and call it mail.do-p.com. I'll create LXC container by first specifying the directory I just created. Then I need to give this container a name, which will also be mail.do-p.com. And I need to download base image LXC will use to create this container. Distribution will be Ubuntu and release will be Focal, which is the latest LTS release supported by iRedMail at the time I'm recording this. You can check iRedMail download page to see if 2204 is supported by the time you do this. And lastly, for the architecture, I'll say AMD 64. We can see that LXC downloaded the root file system, some metadata, unpacked it, and created the container. Note that the container is not running yet, it was just created. There's also a message about SSH. If we want to connect to the container with SSH, we'll first have to install OpenSSH server inside that container. Before we run the container and do that, I want to configure static IP address for this container. Open var lib lxc your container config file and at the end add this line. This IP here is in the subnet we defined when we defined br0 interface in br0.network file. That's all we need for now. You can save the file. We've covered everything from this slide. We have needed directories in place, we've created an LXC, and we've modified containers config to assign a static IP address. Now let's check some basic LXC commands, configure DNS for this Linux container, and upgrade the system. You can list your Linux containers with LXC-ls. But adding -f at the end will provide a nicer output. We can see that state for our container is stopped. You can start a container with lxc-start and then name of your container. And if we check this again, we can see that state is now running, but we can see that the IP address is not set. Let's attach to this container with lxc-attach. And we need to remove Ubuntu's netplan.io package because it is messing with our network settings. apt remove netplan.io-y. Reboot the container with systemctl reboot. Our session was disconnected and we are now back in the VPS. And if I list the containers again, I'll see the IP address I've configured in this containers config. If I try to SSH to this IP now, it won't work because, as that message said, there is no OpenSSH server running inside the container yet. Let's attach to the container again, but this time I want to show you this clear env flag. Without this clear env flag, host will pass its own environment variables into the container, including path. So some commands will not work when the containers are based on another distribution. Before I install OpenSSH server, let's check if our container can access the internet. IPA command will confirm that interface has an IP address. Ping 1.1.1.1 will confirm that container can access the internet, but ping cloudflare.com will tell us that DNS does not work inside the Linux container. If you watched videos where I talked about DNS, you know that there are probably dozens different ways you can configure name servers, and Ubuntu adds few of their own on top of all that. Plus, being inside a Linux container and with different operating system than host makes whole thing even more annoying. Currently, the etc resolve.conf inside the container is symlinked to this stub-resolve.conf, but I need it to be linked to resolve.conf. So let's overwrite this symlink with run systemd resolve.conf. And now we need a drop-in directory in etc systemd resolved.conf and .d at the end. And let's create a file inside that directory, name it override.conf. In it, I'll add a resolve section with these two lines, DNS and fallback DNS. Save the file, do systemctl restart systemd resolved, and ping cloudflare.com now works. In another shell inside the container, we can now upgrade the system, apt update and apt upgrade -y. And now let's install OpenSSH server. Systemctl status sshd will tell us that sshd is running and that it is enabled because vendor preset is set to enabled. Now I need to add my public SSH key to the .ssh authorized keys file, but first I must create .ssh directory and set proper permissions. And I'll add SSH key with this snippet here. Back on my laptop, I'll add an entry to the .ssh config file, which will look like this. This means when I type sshmail.do-p.com, SSH will try to connect to this IP here, which is the private IP of the container. But it will use the previously defined do-p.com host as a proxy. So it first connects to this host, and then from there it can reach this private IP. Let's test that with sshmail.do-p.com. I am sure. And great, we are inside the container. If at this point I reboot the VPS, the Linux container will not start automatically. Let's open main.yml inside lxc tasks subdirectory and add a few things. First, I will copy the backup script to root scripts directory and its companion file .env lxc backups. Then I will add this script to root cron, and finally I will enable the systemd service lxc@mail.do-p.com. When you see this @ symbol in systemd service, it means that that service takes a parameter, in this case the name of lxc. Save the file and open the backup script in lxc files subdirectory. In the beginning, we are setting some variables and making sure that backup directory exists, but here is the main part. It stops the Linux container. It then creates an archive from container's file system. It copies the container's config and it starts the container again. That's all you need to backup Linux container, its file system and its config. It will also delete some older backups, and finally it will write results of the script to the database using this function at the top. And here is the .env lxc backups file, which will hold some of these variables, including the database password. The script will read all key value pairs from this file and use them as variables. It's important that this file is in the same directory as the script. At some point in the future, we might add all this Ansible stuff to a Git repository. And since this file contains a secret, make sure that you have it in a .gitignore file. Otherwise, it will end up in a Git repository and you don't want to store secrets in it. Save this file and open .env backups file also in files subdirectory. It will hold these two variables, name of the Linux container and MariaDB password for the backup script user we created earlier. Save the file and in virtual environment with LXC role uncommented, run Ansible playbook again. Ansible has finished and we can see that only these new tasks were executed. First, script was copied to the VPS, same with .env backups file. Then the script was added to the root cron and lxc@mail.do-p.com was enabled. Over at the VPS, if I check the root cron tab, I will see this new entry. And if I check the status of lxc@mail.do-p.com, I will see that it is enabled. Let me show you how this lxc@ service looks like. So everything after the @ symbol is a parameter and it will be used in place of this %i, in this case to start or stop the container. Let's reboot the VPS and confirm that our Linux container will start automatically. VPS rebooted and lxc-ls-f will say that the container is running, and if I check the output of systemctl status lxc@mail.do-p.com, it will confirm that. Let's test our LXC backup script to make sure that everything is in order. After a minute, script has finished. Storage backups lxc@mail.do-p.com has two new files, the containers file system and containers config. And MySQL-e select star from backups.list will show that execution of this script was recorded in the database.